Hello students, following question is a 2-mark question from test series 2 from subject of structural analysis from analysis of statically determinate structure where we have to find the displacement response of given beam. Now if we see this beam AB at point B, a concentrated load point P is acting, and it is asked that what is deflection at B. Now the difference between this cantilever and simple cantilever is that this is a non-prismatic structure, since EI, that is stiffness, is varying along the length. So here we will be using conjugate beam method, but student can use it according to their convenience, the method they feel they are comfortable with. So I have outlined the steps of conjugate beam method for quick reference. That first of all we have to change the boundary conditions according to conjugate beam. Now for a fixed end becomes a free end when we draw the conjugate beam of a given beam, and free end of conjugate beam is become fixed end. So first of all we'll draw the conjugate beam of AB. Now since end A was fixed and B was free, in conjugate beam B will be a fixed end and A will be a free end. Now also it is said that loading is represented by M by EI of original beam. Now if we talk about bending moment diagram of given beam AB, it will be something like a triangular portion which will be having maximum value at end A given by P into L, but we cannot divide it straightforward by EI because stiffness is varying along the length. Hence we cannot write this expression for bending moment directly, but we have to analyze it by parts. That okay, M will remain same, P into X for original beam, but at this point where just at right of this point it will be PL by 2 EI, but just left of it, since EI is getting doubled, that is it is becoming 2 EI, the value will become PL by 4 EI, and at the end it will be again PL by 2 EI. Now fourth point says that shear force represents slope and bending moment of conjugate beam represents deflection if loading is represented by M by EI of original beam. So we have done step 3. Now next step is left to find the bending moment at end B because of this type of loading, that is because of bending moment of original beam. So bending moment at B comes out as because of this triangular portion, that is area of this triangular portion multiplied by distance of centroid from B plus area of this trapezoid multiplied by distance of trapezoid from B. Now some of the students might find it difficult to remember the formula for calculation of centroid of trapezoid. Here I have outlined the small procedure that area of trapezoid will be half into sum of parallel sides, that is PL by 4 EI plus PL by 2I into length, which is L by 2 in this case, since this portion is up to AC is L by 2, from C to B it is L by 2, and distance of centroid can be calculated using formula x bar equal to A1 into x1 plus A2 into x2, where I've divided this triangular portion as A1 and rectangular portion as A2, and this trapezoid is composed of this triangular plus trapezoidal. So x bar, that is distance of centroid from point C, comes out as A1 x1 plus A2 x2 upon A1 plus A2. X1 is L2L by 3, that is distance from this vertex of this area A1 will be 2L by 3, but here L is L by 2, so 3 into 2. That's what I have written, 2L into 3 by 2. And distance of centroid of this triangular portion of length L by 2 will be A2 into L by 4, because centroid will be located at distance L by 4, and A1 and A2 for both portions can be calculated using simple triangle formula, that is half into length into height, which is PL by 4 EI, and A2 is PL by 4 EI into L by 2. Upon substitution of all these values, just this value simplifies to 3 by 16 PL cube by 3 EI, making C, not C, in fact B as the correct choice. C is not correct, B is the correct choice for given question. Thank you.